Hey all, welcome to the sixth video of the CSES problem set of DT. And this question is pretty basic and straightforward and trivial. So, if you haven't read the question yet, I encourage you to go and pause the video and just read the question and try to do it. So, let's see the question. So, the question says that you have been given a n cross n grid in which you have some squares, and those squares may have traps. And the traps and you have to reach from 1 comma 1 till n comma n, and you can move only right or down, right? And you can't step on a trap because you don't want to step on a trap, right? So let's consider this. So consider a 4 cross 4 square. A bit hard to. So I'm currently at this position. I want to get to this position, right? So at this position, I have these two options. Either I go this way or this way, right? And similarly on this position, I can get on this way or on this way. Similarly on this position, I can get this or this, right? So this is one way of looking at the problem, right? And I have to count the number of paths, right? The number of paths from upper left square to the lower left square. So let's look at the solution little bit differently, right? I didn't want to actually remove all this because then I would have to make the right. So I'm here and I want to get here. Suppose I've reached here, right? And I can reach here from which block? Right? This is the question. That I can reach here, okay, but from which block? I can either reach from this block or this block. Are no other ways to reach it directly because the previous step would have been from this block or this block only because I can move only right or down, right? I can reach from this block or this block only. So same question arises here that how many then I can get from I can get to here from which one. So you can get from this or this, right? Also, you cannot get from a trap because you won't step on a trap, right? Also, if it is a trap, you can't get from this now. You can only get from this. So you can get a backtracking approach here, right? You get a feeling of it, right? So the question is based on this approach only. This approach is known as course. We are going from uh, uh, top to down, I guess. So it is a top-down approach. You can have a bottom-up approach as well. As you start from bottom, you go till up, right? Both approaches are valid. So let's discuss first approach, right? So if you are at a position, and so we discussed that if you are at a grid ij, so let's get to sublime here. So if you are at a block ij, I comma j, you can get there from I minus 1 comma j or I comma j minus 1 if I and j are greater than 0 first. Also, we can't have a trap on these cells only then we can get from here, right? So currently, suppose a 3 cross 3, 3 cross 3 star sorry, dot star dot star, right? It actually looks like a 4 to me. So let's see how would I traverse from this point. Alright, from this point, either I can get to this point or this point, but I can't get from this point because it is a trap. So when here, I can either get from here or here, right? When here, I can't get from here to here because this is a trap, right? There is no way from getting here to here. Then for getting here, there is only one way because the upper one is flat. And to get here, there is only one way. Alright. So what I would be doing is that I would be maintaining a DP array of of size 3 or 3 filled with zeros initially. Right. What I would be doing is that I can get from here, or here, but I can't get to here because it is a trap, right? It is a trap here, so I can get to here. What I would be doing is that I would replacing it with plus one. Uh, uh, Similarly, for this also, I would be replacing it with one, and this as well with one. Suppose it is not a trap because there would be only one way, and I don't want that. So suppose it is not one, and I can get to here. All right, so I can get to here from here. So I would mark it as one because the number of ways is one only, and then I would mark it as two because here the number one, and this would be dp ij plus one. So two here, and similarly two here, right? Oh, sorry, not two actually, because there is one way of getting here and two ways of getting here. The total number of ways to get here is three, right? Two plus one is three. One plus one is two. One plus two is three. I just have to add the adjacent multiple. So dpij would be equal to dpi plus one j plus dpi j plus one. And our final answer would be dp 0 0. We could do it the other way around as well. We can iterate from our zeros. To get this way, we have to iterate from for I is equal to n to 0, right? Similarly, for j is equal to n to 0. We can do it other way around as well. We can do for I is equal to 0 to n, and j is equal to 0 to n, and this statement would be changed slightly in a slighter way. I would just require I minus 1 j instead of I comma j plus 1. Right? The plus sign would be converted to minus sign. Why so? Because if we consider again this example only, so it is initially equal to 0. So I can consider this. I can get from here, get to here from here only, right? So there is only one way, right? There is only one way. Similarly, for the second one also, I can get only from here only, right? So there is one way. Then on this, I can get to it from upward only because the left one is not possible because it would have a negative index. Now for here, I can get to either from upward or from the left one. So this would be this one plus this one. So 1 plus 1 is 2. And for this also, 2 plus 1 is 3. You can get to this block from this or this. So 2 plus 1 is 3. I can't get to this block because it is a trap. It is a trap. And for this, I can only go from this to C. Right. So pretty straightforward approach here. And now let's jump to code. I hope it is. I hope the approach is clear to you. Let's just move. So yeah, I have used actually. I have used an recursive function. So let's not look at my code. Just I would just code it again with the same thing. Right? And I have to input. I have to just in, and I have to output the number of parts. Right? So I'm using the same, and I have to construct a DP of size n percent and initialize it with 0. Right now, I would iterate with it. I'm using FI and FJM because it is defined as macros. Right? SIN is foreign type equal to 0 LSN and SCN is foreign type equal to 0 GLSN. Right? And DPIJ will be equal to DPI minus 1 to the DPI J minus 1. And I have to make a mod as well, percentage mod. Right? Also, I can't have a negative or let's say if I have any of these, if I have I is equal to 0, then I would just make it a 1 because there is only one way, right? Similarly for j is equal to 0, right? And at last I have to output dpn minus 1, right? I think we are done here. Let's see if it works for this. Oh, I forgot that. So just a minute. I forgot simple thing here that it is a character array. I have to input a character array as well. Right? And after inputting the character array, and if it is a trap, which is k ij is a trap, then dpij is equal this, right? I don't think anything like now. Let's see if it works. So, I have three ways. So let's save it and start it. I get a wrong answer here. Yes, not, but wrong answer here. So user output is 0. Okay. Uh, there can be a way. Okay, okay. So I have to consider the at least dp minus 1 j or dp j dp j positive minus 1 j. Also a condition if both are 0. That's modify and j in dp ij would be equal to that because if it is a star then I will have marked it as yes, it should work now. Let's see. Yeah. So there was just a few checks. So this is the iterative approach here, and as you can see, it is pretty straightforward. So let's see a recursive approach for a bit. The recursive approach is also similar. We would return dpj is equal to fn x plus 1 by fn and x y1 plus 1 and percentage more. And we just memoize it by using dpxy. Right? And these are the several checks we use. And it is pretty straightforward to you as well because we have already coded the iterative version. So that's it for this question. Question was pretty easy. Now let's see a spoiler of the next question. As you know the price and the number of fields, I have done a lot of wrong things there. So decide that total price of your purchase TV at means what is the maximum number of TVs you can buy. So by okay. So this actually it is a slightly bit difficult problem. I think it's kind of falls in a medium category. And I won't give you a hint because it is actually if I gave you that hint, it will just spoil the enjoyment of this problem. So try to do it yourself, and I would of course make a video from this. So let's have a break then. Till then, bye bye.